Welcome. Today we're going to talk about the business value of continuous integration, continuous delivery, and DevSec Ops, and how to scale up your product and service delivery life cycles to multi-billion end-user global systems of systems using containerized cloud-based microservices. Feel free to visit my website where you can get this briefing and all of my videos and white papers on how to apply these concepts to complex systems. I've been an IT management consultant for nearly 4 decades. My background is in computer science. I'm a career systems and software engineering process strategist. I published the first books on the ROI of CMMI as well as Agile methods, and I specialize in Lean, Agile, Scrum, Safe, DevSecOps, and cloud computing. By now, most of us have heard of the Internet of Things, with tens of billions of devices and hosts on the Internet, billions of mobile phones and end users, placing enormous pressure on today's businesses, making the IoT an extinction level event. DevSecOps has emerged to help mitigate this extinction level event, which is an early, iterative, and automated combination of development and cloud-based operations based on lean thinking and agile methods, as well as principles of collaboration, teamwork, iterative development, and responding to change, which is a closely related family of techniques that when used together help maximize business value, success, and global resiliency. So how does DevSecOps actually work? Well, in this paradigm, requirements are implemented in slices versus layers. Instead of implementing overscoped, unneeded systems using traditional methods, fewer value-adding requirements are implemented first, resulting in earlier ROI, lower costs, fewer defects, manageable risk, better performance, and a smaller security attack surface. At its heart, DevSecOps is based on principles and practices of lean and agile thinking, such as one-piece workflow, as illustrated by these cumulative flow diagrams. When you increase your batch sizes using traditional thinking, this elongates lead and cycle times as well as decreases quality and security. However, when you dramatically reduce your batch sizes using DevSecOps practices, this reduces your lead and cycle times as well as dramatically increases quality and security. Over the last decade, a family of closely interrelated concepts has emerged to help us improve the success and reduce the risk of developing innovatively new products and services by reducing our scope, scale, size, cost, and risk in order to increase testability, quality, reliability, security, morale, maintainability, and even success. The secret sauce to the modern information technology revolution is clearly the notion of microservices, which are small autonomous applications. Instead of building overscoped applications using traditional thinking at a cost of decades and billions of dollars, we build much smaller applications and we tightly wrap them in containers, replete with the image, middleware, and operating system. Then we fully test and secure them and deliver them to billions of global devices in fractions of a second using DevSecOps practices. Modern organizations have the luxury of creating microservices from the very beginning. However, 80 to 90% of global organizations have their IT budgets wrapped up in legacy systems from the 1960s and 1970s. Therefore, guidance is emerging to help them decompose their monolithic legacy applications such as domain-driven design and service-based architecture so they can catch up with the rest of the world in terms of microservices. Modern information technology enterprises have the luxury of creating their microservices directly in the cloud. However, when you do this, it shifts the responsibility of infrastructure and application security from the IT data center operators to the application developers, thus increasing the necessity to apply rigorous DevSecOps principles and practices. The DevSecOps revolution or evolution didn't happen overnight. It's really a family of closely interrelated techniques from the 1990s that manifested themselves as textbooks in the 2000s, such as test-driven development, continuous integration, behavior-driven development, continuous delivery, DevOps, DevSecOps, and even microservices. Once again, the revolution or evolution of DevSecOps practices began in the 1990s with extreme programming and test-driven development, where small pair programming teams pulled user stories off the backlog one at a time, writing and running their tests to fail, then writing their code and rerunning those tests until they passed, refactoring their code to work out the waste, thus improving delivery speed, quality, and even security. This slide illustrates some basic test-driven development concepts of analyzing the user stories to understand them, writing acceptance criteria, developing unit tests, running those tests, writing the actual code, rerunning the tests until they pass, and then refactoring the code to its smallest waste-free state. Another closely related practice is behavior-driven development, which focuses on writing and running tests at the feature level versus the user story or individual code unit level. That is, those tests are written and run until they pass. Developers are allowed to write their user stories that belong to that feature, and then the feature tests are run over and over again until they pass, or at least the code units satisfy its feature acceptance criteria. This slide illustrates the basic behavior-driven development concepts of analyzing the feature, writing the acceptance criteria at the feature level, not just the user story level, writing feature level tests, running them, allowing developers to develop that feature, and then rerunning those feature tests over and over again, and even refactoring the feature until it satisfies its feature level acceptance criteria. The next major revolution or evolution of DevSecOps practices is clearly the notion of continuous integration, where developers check their code into version control servers as they write it. The code is automatically built and tested. If it fails a test, it's kicked back to developers for correction, and if it passes, it's pushed out to staging servers or even production servers if possible. This slide illustrates some basic continuous integration concepts. As developers check their code into version control servers, it's automatically built. This includes the database. Automated static analysis tests are run. Automated functional tests are run. Feedback is automatically generated and sent to all stakeholders. Documentation is automatically generated. And if the code passes all integration and functional tests, it's deployed to staging servers or production servers if possible. The next major revolution or evolution in DevSecOps practices is the notion of continuous delivery, whereas continuous integration focused on building and testing software as developers checked it into version control servers. Continuous delivery focuses on final packaging, acceptance testing, security analysis to ensure that the software is professionally packaged and satisfies all of its final market and end user requirements before deployment and delivery to production servers. This slide illustrates just some of the basic continuous delivery concepts such as final packaging, acceptance testing, load testing, performance testing, pre-production testing, certification, and even deployment if the software satisfies its final end user or market requirements. The next major revolution or evolution of DevSecOps practices is clearly the notion of development operations. That is the collaboration between development and IT operations, maintenance, and support, whereas most of the practices we've described so far show developers how to prepare their code for production to the IT operational state. DevOps shows IT operators how to help developers prepare their code for production, maintenance, and operation. This slide illustrates just some of the basic development operations concepts, such as system administration, configuration management of the production code, the host builds, virtualization, containerization, deployment, and even monitoring, support, and rollbacks. Many of these tasks are now being subsumed by the developers themselves. The next major revolution or evolution of DevSecOps practices is the notion of development security operations itself, which is a triad of security engineering, secure microservices, and secure operations. That is, the applications must be carefully engineered to be secure from the inside out. The microservices themselves must be carefully secured, and of course the IT platform must be secured and the applications carefully monitored as they are operating on production servers. This slide illustrates just some of the basic development security operations practices, such as baking in security as the microservices are being developed. Carefully securing the containers that will hold the microservices, evaluating the applications from inside the containers as well as outside the containers, deploying them in a secure way, protecting the microservices while they're on production servers, monitoring the production servers and microservices, and of course carrying out careful security responses when vulnerabilities are detected. Another major revolution or evolution of DevSecOps is the notion of enterprise DevSecOps. That is, modern businesses such as Amazon can conduct hundreds of thousands of DevSecOps business experiments every year instead of multi-decade-long, multi-billion-dollar traditional systems releases. The Scaled Agile framework is just one such model or framework that embodies these modern principles, practices, and concepts. This slide illustrates just some of the basic enterprise DevSecOps concepts, such as converting business objectives into strategic themes using OKRs, synthesizing epic hypothesis statements, conducting lightweight lean UX activities, forming business experiments, developing a DevSecOps ecosystem to conduct those experiments, collecting feedback from end users, and most importantly, pivoting or persevering based on that feedback. Let's examine just some of the basic tools for developing DevOps ecosystems. There are tools for coding and committing like Visual Studio and Eclipse, building and converting that code once it's checked into version control, scanning and testing the code, releasing to staging servers, and deployment to production servers. There are literally hundreds of configurations for DevOps pipelines. See these references for more information. Zebia Labs developed this popular periodic table of DevOps and DevSecOps tools, identifying tools for configuration management, database administration, continuous integration, testing, deployment, containerization, analytics, monitoring, security, and even collaboration. Once again, DevSecOps is all about baking in security rather than icing it on at the end. So let's examine some of the basic DevSecOps tools. For instance, there are tools for securely coding, secure configuration management, secure storage, building in a secure way, and of course deploying and monitoring and responding in a secure way as well. Much like Zebia Labs, the SANS Institute has developed a secure DevOps toolchain or DevSecOps periodic table with tools for the pre-commit stage, commit or continuous integration stage, acceptance or continuous delivery stage, production or continuous deployment stage, and of course production operations. Let's examine some basic DevOps metrics. Test coverage uncovers dead code, which is a major problem among programmers. Test automation measures automated versus manual tests, which is very important. Increasing integration builds dramatically decreases defects, and automating the DevOps pipeline dramatically increases delivery speed as well as reducing lead and cycle times. Let's examine some advanced DevOps metrics such as deployment frequency, change volume or churn, lead time from development to deployment, number of failed deployments, mean time to recovery when those deployments fail, customer ticket volume, change in user volume, availability of the system, performance of the system, as well as some lead metrics associated with business experiments. DevOps metrics often get embodied in DevOps assessments that measure IT performance, lead time for deployments, deployment frequency, mean time to recovery, change failure, burnout among IT workers, as well as deployment pain. Let's examine the DevSecOps cost of quality, which is up to 2 orders of magnitude better than traditional methods. That is, running thousands of automated tests on a few DevSecOps small batches or business experiments is a fraction of the cost of running a few manual tests on large traditional batches, as illustrated by the orange and red bars on the right. Let's examine DevSecOps principles and practices at Hewlett-Packard, who reduced their build time, increased the number of builds, improved their feedback, performed more regression testing, decimated their development cost, and more importantly, returned 80% of their development costs back to innovation and experimentation, dramatically improving their business posture. Let's examine some .com DevSecOps case studies. Assembler went from 2 to 45 releases per month, which is 50 to 5,000 times faster than traditional IT projects. 15,000 Google developers run over 150 million automated tests per day, and 30,000 Amazon developers deliver nearly 140,000 releases to their production baseline every day. Here's a fascinating DevSecOps case study from 2005 to 2009. Blackboard integrated all of their code into one massive ball of yarn, freezing productivity, overwhelming their test system, and dramatically increasing the number of defects when they used domain-driven design in 2010 to decompose their enterprise architecture into microservices. Their productivity and quality shot through the roof. They decimated their cost of quality like Hewlett-Packard, returning the extra operational cost to innovation and growth. Here's another fascinating DevSecOps case study from the U.S. Department of Homeland Security, who transitioned from traditional waterfall practices to DevOps in only 5 years, reducing their deployment times from 180 days to about a day and a half, reduce the number of artifacts or documents from 20 to 2, that's an order of magnitude, reduce their manual governance gate reviews from 10 to 1, thus empowering their developers to make the releases with automated governance. Here's another fascinating DevSecOps case study of high-performance all-electric Tesla automobiles, which are basically iPhones or iPads on wheels with over 200 million lines of code. Tesla performs over 130 secure software deployments to their fleet of automobiles to optimize your performance, battery life, and range. Many traditional industries are following suit for mission and safety critical systems that contain human passengers. Here are a few more fascinating DevSecOps case studies. Google obviously performs 40,000 code commits per day and 150 million automated tests that go along with that. Netflix does self-service deploys with 0 downtimes. Amazon, of course, does 136,000 deploys per day with very tiny 2-pizza teams, and Target does 80 deployments per week with self-service dojo training, and Bing or Microsoft does 20,000 code commits per day, and every clean build is deployed to production servers. Here's a fascinating DevSecOps business case by DevOps Research, illustrating that the average return on investment for DevSecOps is about 50 to 1. dispelling earlier myths that DevSecOps was beyond the budget of the average bear. However, there are still some gotchas if you try to implement your DevSecOps pipeline in a traditional brick and mortar data center versus a cloud by Microsoft, Google, or Amazon, or any myriad of other cloud service providers. Here's a fascinating study by Stefan Tomke of the Harvard Business School illustrating that enterprises that can deploy rapid business experiments to their production fabric using DevSecOps ecosystems can actually increase their stock market performance by nearly 20 to 1 over firms who cannot do likewise. DevSecOps principles and practices are finally taking hold after nearly 25 years, with 74% of teams starting to use DevSecOps as of 2019. However, at the enterprise or the firm level, DevSecOps principles and practices are still a little bit slow on the uptake. While there is no well-accepted standard definition or unified theory of DevSecOps principles and practices, this roadmap is a very, very helpful tool here. At the basic level, we see DevSecOps embodies continuous integration practices. In the middle, automated test practices. And on the high end, how you operate your virtual cloud data centers. Here's a fascinating technology adoption curve of DevSecOps principles, practices, and trends. At the basic level, firms are focusing on general DevOps principles, containers, cloud computing, and basic tools. More advanced firms are focusing on business experiments and entire DevSecOps ecosystems. Even more advanced firms are focused on automated testing and developer experience, while the most advanced firms are focused on AI and machine learning. In retrospect, here are just a few major keys to successfully applying DevSecOps principles and practices. First of all, apply lean and agile thinking at scale. Keep your portfolios lean and mean. Radically downsize your monolithic legacy system applications and architectures. Apply microservices and automate your end-to-end information technology fabric for rapid business experimentation. Contrary to the claims of traditionalists who simply do not understand the mathematics of lean and agile thinking, DevSecOps does not mean deliver it now and fix it later. It's a lightweight yet disciplined approach to developing innovatively new products and services that reduces cost, risk, and waste while improving quality based on principles of early feedback, focused priorities, vicious simplicity, extremely small batches, radical teamwork, early and automated verification and validation, and of course, ironclad security. So what's the bottom line? DevSecOps ensures enterprise success by delivering large volumes of valuable, reliable, and secure IT products and services to billions of global end users in fractions of a second. Thank you for your patience, time, and consideration. Feel free to visit my website where you can get this video, briefing, and all of my white papers on how to apply these concepts to complex systems.